Good afternoon or morning, depending on where you are in the world. My name is George Palikaros. I'm the founding president and CEO of Meta Materials Inc. Our NASDAQ symbol is MMAT. We are currently going through some incredible changes that I would love to share and some of our progress today with you. As it's customary, some forward-looking statements. I'm going to spare you from going through the gritty detail, but you can understand these are standard. So a little bit about Meta. So Meta is a unique, in our opinion, company. So Meta, we say that we deliver solutions for everyday life, but what we do is really the core science, which leads to breakthrough performance in smart materials. These smart materials unlock unprecedented product performance for our customers and for everybody. That's why we say for everyday life, that is the beneficiary of our products, allowing them to be better connected, more secure, and more healthy. And we do this by designing, developing, and manufacturing nanomaterials. These nanomaterials are not only highly functional, but they're also sustainable. And sustainability for us is core to our belief. For example, we try to do more with less. We have won several awards, including the Global Cleantech 100. This year, we were awarded by the Canadian government for Cleantech 50, and more to come. One of the interesting things is that we are the only metamaterial company today on the NASDAQ that has the capability to design, develop, and manufacture these smart materials. There is a number of other metamaterial companies that they're early stage, venture-backed, and certainly not on any exchange. So if you're an investor looking to take and participate in this incredible nascent market opportunity, which is estimated to reach $10 billion just for a metamaterial application, then Meta is where you would start. And we have several advantages. So the company started about 10 years ago. About a year ago, I presented at this forum. And since then, we have made incredible advances. We have grown acquisitively. We took into account the fact that we were going through a pandemic. Like everybody else, supply chains were stretched out. So last year, when we entered the NASDAQ with roughly $150 million in the coffers, we had the capital to execute. But to execute faster, we decided to acquire a company called Nano-Optic Security Corporation. And that brought us several things that we were missing. Number one, we brought highly skilled manufacturing experts. The company we acquired was in the security printing business, and they needed to be not only high volume means in the nanoscale, kilometer length roll-to-roll type processes, basically being able to print at the speed of printing newspapers, but also the skill set of making it precise, controllable, and also repeatable. So with that, instead of going and purchasing equipment, which would have been cheaper, we took a different approach. We acquired some assets that not only enabled us to scale up quickly, but also allow us to have more mature conversations with customers who, if you think of the market verticals we play in, anywhere between healthcare, automotive, consumer electronics, aerospace, and energy, they have very high demanding needs for volume and quality. So we have demonstrated these advantages throughout the last 10 years. As a result, we have won incredible trust and confidence that has been presented in press releases. This year alone, the last big press release was with PPG, a global supplier and developer of innovations, who is becoming fast part of our strategic network of suppliers. Previously, we had Covestro. Some people in Germany will know they spun out of Bayer Materials. Covestro is a leading company in polycarbonates. This year, we also announced a partnership with Sekisui, yet another tier 1 chemical company from Japan, on our 5G application. And finally, we are working on very large partnerships across the field that not only provide materials, that's kind of the least that they offer, which we still are looking for, better and better prices. However, the real strategic value comes from the network that they have. They open doors for us, and together we go after solutions that take commodity products and turn them into something very special. As a result, we have been expanding our capabilities through acquisitions. We have added not only in the nano printing side, not only on the design side, but now we are working on precision integration. And what that means is that a customer previously would come to us for a design, and we would source, this is like 5 years into the business, a supplier, and work collaboratively. This added a huge amount of time to kind of manage all those relationships and risk, because you had to rely on larger corporations that may not have moved as fast. Later, we added capabilities of nanoprinting, where through holography especially, and lithography later on, we started being able to do pilot runs at scale and basically at the right cost, winning business. But then came the point where our customers started wanting more, and they wanted integrated solutions. So semi-finished products like a door of a microwave oven, or putting our product on a headlight, or putting film on eyewear that becomes smart display eyewear. And even further downstream, or in the mid to long term, where we see ourselves moving into a device and further adding value in a complete solution package. So together with all this, we have reached now over 450 active patents. These patents, if you think of them as options, they provide a huge amount of value, not only to ourselves, but our partnerships, because together we form alliances with companies that have multiple of those patents. So imagine a PPG, which has tens of thousands of patents, adding that component, that piece that binds it all together, let's say, allows us to basically think more strategically as we enter the marketplace. Now, I want to focus a little bit in the next section about what we are doing in the battery and the electric vehicle space. So in this space, it's a very one of the highest growth areas. We have been making batteries in the last 2 months in partnership with a company called Coulometrics. We have started working on LFP type batteries, and we will continue on doing NMC type batteries. So we have had 2 sets of reports. The results are very promising. One of the highlights here is integrating materials that make batteries more stable, more safe, and basically reducing the weight, reducing the cost. And one of the key challenges here is how do you make batteries safer so that higher energy density and charge rates can be allowed. So we have 2 technologies here. One we call NPORE, so nanoporous ceramic materials. Basically, the pore size is less than 100 nanometers. We control it very accurately. This material is special because it has demonstrated that it can shrink less than 1% when you heat it up, compared to other materials that increase sometimes 10 to 20%. And that is a critical aspect in a battery safety and electrochemical performance. And on the other side, plasma fusion, which is not just a material, it's actually a technology, which allows us to coat any material on any material. So think of this as a way to reach solid state batteries and basically coat multiple, very complex, both in stoichiometry and also design coatings on films. We have talked about plasma fusion and NPOR in previous press releases. Each one represented an acquisition. Now there's incredible fit between what we're doing in the battery space as well as across the different functions of the company. From NanoWeb, which is a transparent metal, to our medical applications, to our automotive applications. These materials here, even though they are destined for batteries, they have other use cases which are very, very promising. So continuing on with what is happening right now in the market, the specific segment for these separators is estimated to be worth $9 billion by 2025. And this corresponds to about 15.8 million meters square. Today, we have a small volume, if you can call that small, which is in the size of 400 millimeters with an external partner web roll at about 1 kilometer runs. The good news there is that you can take this 400 millimeter roll and slit it a few times, and it will still fit the envelope of the battery. So in essence, with one run, we get about 5 kilometers of film when it's slit. And it cost us, in terms of raw materials, roughly about $1 per square meter. And we have roughly 80% or more in terms of margin when we are out there pushing the product to the marketplace. We currently are working on licensing agreements. We have discussions with large corporations, tier ones and tier twos. There's a number of tests going on in the background, and we feel very strongly that in the coming months, we will see some exciting news. So I want to show you how the battery works and then talk a little bit about the statistics. So hopefully this plays for you. So what you see here is two types of batteries. The only difference is the same type of battery. The only difference is the separator. On the right is the control. On the left is the NPOR. So as you can see, there is a nail test, which penetrates deep with the right type of pressure. Basically, the material prevents the thermal runaway that happens during this nail penetration test. We are very excited about this, not because it increases safety, but it does not affect any other performance adversely, any other performance parameter. Now you can see you get about 3 times more compression resistance than a typical plastic separator. So from this particular technology, as I mentioned, it's nanoporous. There's more than just one application. So this technology can be used in ultrafiltration. It can be used in our MRI machine as a raw material input. And Optodot managed to create a very extensive portfolio of 107 issued and 26 pending patents. 2 of them were recently issued in the US for NPOR and the NPOR ECS, which stands for basically electrode-coated separator. So with that, we are scaling our operations. We have seen already synergies between our other applications, and we're pushing forward with some of the design wins with certain customers. On the other side, we talked about plasma fusion. And here is what is happening. If you look at dissect a lithium-ion battery, you can see here the separator in silver. You can see the cathode in kind of yellowish color, the anode in kind of bluish color. And what you notice here is that there is a cathode current collector and the anode current collector. And you know, if you know your batteries, that you use aluminum and copper foils for the cathode versus the anode respectively. And typically these two materials account for 15% of the battery mass. In fact, copper is 3 times heavier than aluminum. And that alone accounts for the most weight in the battery by about 10%. So when you take that, and we have done some experiments with partnerships with DuPont, basically in a controlled way, you can have a very thin plastic that you can coat about 150 nanometers of copper on each side to replace a 15 micron copper foil. So not only you can achieve weight reduction, plastic is lighter than copper, thinner copper than a thicker copper, also lighter altogether. We have shown experimentally that we can increase the energy and power density. And in case of thermal runaway, as the previous example, when the plastic in the middle melts, we can basically increase the safety of these batteries. And finally, the lower copper improves basically recyclability and, of course, cost. So here we have one of our tools. One of the exciting things that has happened in the last few weeks is that we went from being able to make sheets to basically making rolls within this pilot scale program. And with the roll, we have high levels of confidence that we can basically now move to a larger machine that's going to be several millions of dollars, which we plan to build over the next year or so. There are exciting synergies. This was the original reason why we were interested in plasma fusion, was to metallize nanoweb at a higher rate, but also Color-Optic, our banknote materials, basically accelerating the speed of the line, reducing capex and reducing the cost per square meter overall. So moving on to some exciting developments. So we have talked about in previous presentations with regards to our business, we have a solution called Nanoweb. Nanoweb is a transparent conductive film. Some of you may have already seen some of the applications, one of which is de-icing and defogging, and EMI shielding as a subsequent benefit. These layers of transparent film can be added onto any surface. Think of headlights. You can think of major components like windscreens on cars. You can think of side mirrors, inside mirrors, and so on. So with this progress has been made in the roll-to-roll production facility in Pleasanton, where we have shown to some of our key customers, not only how we produce them from our roll-to-roll line, but also basically meeting what we call the gold sample standard, which came from our wafer line. The applications extend to 5G and also EMI shielding. So on the 5G application, we have designed a unique solution that has won a global award. It basically allows signal to reflect and guide in places where there's no signal passively. So our passive window is totally transparent, so it does not change the face and the view for the inside people versus the outside people that view in. And it's 99% transparent optically, but it reflects about 99% the signal towards a direction that is of interest. So you can bend the beam 45 degrees, 30 degrees, and so on. We are currently working with network planners, operators, and we have announced a partnership with Sekisui for the rollout of this product, which is still in scale-up development. Similarly, from our production line, which you can see here in the top right corner, we have our machine that is producing nanoweb for EMI shielding. So you're very familiar with a microwave oven. Has never been seen any kind of new innovation for maybe 30 plus years. We are the first company to develop film that basically is totally transparent and adds more safety to an oven. There's been very large corporations that have tried doing this with indium tin oxide and other types of coatings and have not been able to pass the safety standards. To our knowledge, we are the first company in the world that has been able to showcase this level of transparency with passing and exceeding the safety aspects for EMI. The work that we have done here is ongoing. We have sent our microwave ovens to very large corporations, so there's discussions and developments happening in the background. And we are excited to be sharing more news later in the quarter, in Q4, of how we are faring. When you look at integration, as I mentioned earlier, smart glasses are a big thing. Some people call it the metaverse. So what we see here is a smart eyewear, and it's kind of a blown up version of it. You see the microprocessor, the chips, the batteries, etc. And what we have is a way to address a $1.5 billion market, which is augmented reality eyewear. We have major alliances like the Lazar Alliance, which brings us closer to other manufacturers. We have been working closely with Covestro over the last 5 years to basically automate and create a high volume one-stop shop that allows OEMs, you can imagine the largest OEMs in the world, coming and basically getting not only a design to their custom optic, but also combining it with unique prescription lens technology that covers more than 50% of the market. And we are the only company, as far as we understand it, in the world that can offer the optic, the lens casting, and all the basically components to get full lens designed and delivered in volume to our customers. And last but not least, which is a little bit more mid to long term, these materials, these innovations have breakthrough performance in enhancing imaging and sensing. And you see some examples here covering very large opportunities. On the glucose sensor, which is really, I would say, a lot of the focus and investment has gone into most recently. We have a new industrial device that is being tested, and we hope in Q4 to be testing this with humans and reporting these results later in Q4. On the imaging side, there's our VP of medical imaging, Panos Kosmas, is right now in Milan delivering a keynote with regards to brain scans and basically stroke detection, which is a parallel program that is happening alongside MammoWise. Last but not least, we have some updates in the security product line. As I mentioned, this is a very important product line, not only because of its sticky revenue. When you win contracts in this kind of business, typically they last for 5 to 7 years, but also because this is proof that you can make tiny nanostructures. And in this banknote example, you see about 5 billion pixels concentrated over this stripe. But the key is making it at large scale, reproducible in roll-to-roll format at the right price. And we are achieving that every week. We are very excited that we have currently completed our color optic design for stripe. There are about 6 companies that have received our samples. We're waiting for feedback from them. If the feedback is positive and we don't need to do some tweak in Q4, then we will be announcing officially the product launch of Color Optic. Color Optic is critical for us because it can also be applied as a tack stamp. It can be applied as a strip or as a thread. So there are 3 product subcategories and form factors that can allow us to move forward. New purchase orders are expected, and we will be following up with some results. So since I'm running out of time, I can say this. So our company is very committed, especially our team. They're working around the clock. We have made some incredible progress. Unfortunately, I cannot share every single MOU and letter of intent and do every single press release of the progress that we have in the background. Those will come. I would like investors to still take a look with interest in the quarterly results. We are growing. We have grown in revenue, and we are making sure that our working capital is sufficient to take us forward. We have some incredible opportunities ahead for non-dilutive capital access. We believe that with support from some of our partners, we will be able to progress even further and push harder. So finally, just want to say thank you. We are the first and only metamaterials company on NASDAQ that is able to design and manufacture these nanostructures at volume. We're pushing to make sure that we double our volume by the end of next year. We're looking at Thurso becoming a 15 million meter square facility. Pleasanton is producing materials, so there's tweaking there based on customer feedback and specification. Our Halifax team is excited because we're about to launch our new facility in Highfield Park. This is a 68,000 square foot custom facility with a large number of clean rooms, focusing partly on holography, partly on semiconductors, and partly on the integration of optics and other components in smart materials. So that concludes my talk, but one last thing, save the date. November 17th is when we're going to be doing our grand opening in Halifax. We hope to take some video and basically allow some people like analysts, etc., to visit us. We have a whole plan. It's coming together shortly. We will be making further announcements to that, but you can save the date for November 17th and hope to see some of you there. Thank you.